Hello, everybody. This is Todd Frazee, and this is the CAM tutorial for the mounting body, part number 7310. Okay, so you should already have this modeled, and this is a multiple setup part. We do have a different thing on this particular model. We've got this Century Gothic text. I do believe this 20 thousandths deep is an error. That's too deep. So we're actually going to, with the size cutter we have, we are shifting next semester to an engraving tool that probably could do that. But for this semester, if we're using an 1/8 inch ball cutter and we cut 20 thousandths deep, even with the size of this text, it'd be too deep. It'd wash it out. So we are going to program that as if it's on the surface, and then we will lower it at the machine till we have a desired result. And who knows, that might be Rev 1. We'll have that note fixed. Anyway, we want to pay attention to the notes. We're going to open our part in Fusion. Now I realize in when I did initial tutorial on modeling this part, I believe I omitted this countersink. If you're missing that countersink, you're at this point you want to go back in and fix that. So we're going to highlight this feature here. We can see it's this whole feature in the feature tree. Right click on it, hit edit feature. You may have done a plain hole. Just change it to a countersink, and then you'll have to update the fields to reflect what you see on the screen here with a 300 thousandths diameter countersink and these parameters. So I apologize for that if that was missed in the revision of the modeling video you did. We want that in there so we can do the countersink. Okay, it may have been omitted. Another thing we're going to add that's going to be on the next revision of the drawing is we're going to go ahead and add some features on the outside perimeter. It's going to help us with deburring. So the drawing, if you look at it, calls for a deburr all sharp edges with an R.01 10 thousandths. Typically, most shops don't care whether that's a radius or a chamfer, so that note probably should be changed to remove the letter R. But what we're going to do is, since we're going to cut from this angle the perimeter, let's go ahead and add those to these vertical edges, and then we won't have to do the hand work on that as much. So we're going to go to fillet, and we're going to pick on, we're not going to model them all because we're not going to model them all because you know, we would maybe run over this with a chamfer mill. So let's do a chamfer instead of a radius. Okay, so we got a chamfer, and we're going to pick on the vertical edges. Should be 6 of them. Okay, those 6 edges. And that's only because we're cutting them in profile. Yeah, the chamfer tool works better with the chamfer command in the CAM works better if the chamfers aren't modeled. So we'll run those around the outside there. So our chamfer says 10 thou max. We're going to do 9 thou, so we're slightly smaller. And that way we're not going over the 10. And hit OK. And it'll be pretty subtle when it comes to the machining. It'll go around those corners, but they won't be quite as sharp. Okay, so let's draw our stock. We need to reference our traveler. So this is 1 inch by 1.5 bar stock cut to 8.1 or 8 inches and 100 thousandths plus 100 minus 0. So this is the size we want to draw our stock. And I believe in plan view for our first op, the 1 inch is going to be one side of our rectangle of our stock, and the 810 is going to be the other, or 8100. Okay, so if we're going to look at this in the top view, okay, we're going to sketch in the top view. And we're going to draw a rectangle. And we're going to set our length at 8.1 or 8 inches and 10 thousandths. And then our width is 1.5. I'm sorry, it's 1 inch. Okay, now we need to center this on our stock. So I'm going to exit the dimension tool, move this a little bit. I'm going to draw a line from corner to corner. I'm going to highlight that with the left mouse button, then the right, turn it into construction. And we're going to draw another line. I'm going to draw another line from the length of the part. And then we're going to align that to midpoint of that silhouette edge. Then on the opposite side, we're going to hold the shift key down, get the outside perimeter and the end point, and we're going to make that coincident. Okay, that'll constrain that line. I'm going to right click on it, create a construction line out of it. And then now we can use the midpoint tool and pick on our two construction geometry lines, and that'll center our stock and constrain our sketch. Okay, we're going to do finish sketch. And we're going to extrude this in two directions, two sides, because we need to take a little bit off both sides of the part. So in the first direction, it's going to be 1.5 inches minus whatever we remove off the other side. So let's go 1.47. That'll leave 30 thousandths on the opposite side to remove. And then in the opposite direction, we're going to go 0.03. So our total distance, when we do that, should be 1.5 inches. We're not doing a cut, we're creating a new body. And then we're going to hit OK. Now let's expand the bodies folder, and the first body is our actual part. Double click on that, we're going to rename it 7310. Then the other body, the one that's on the outside, the second one is going to be stock. We're going to right click on the body in the menu of the stock. We're going to go opacity control and go 50%. And that way we can see through the stock where our part is. Okay, so now we have the stock established. Make sure you're saving frequently. We're going to start doing our setups. Okay, now we're going to set up our different operations. So to do this part, it's easiest to use the left side as our, what I've shown as the left side as our datum. So our text will appear upside down when we're machining it, but we want to be able to pick on the machined edges that we're clamping to for our operations. So we're going to turn it like this, and then we're going to bring in our vise assemblies and assemble this with the vise for each operation. So first operation will be this side. We're going to qualify the top plane, and then we're going to run around the perimeter of it, establish the perimeter cutting, and then we'll come back and use a chamfer mill to deburr that face. Operation 2, we're going to roll the part like such and remove the hat on the top, machine the top surface, and machine our text. And in that instance, most of the stock will be removed. And then our next operation will be to lay the part flat like such. We're going to do the holes and the chamfers on that side. And for all those operations, we can keep the origin on the left in the same spot, because those holes will be made in relationship to the left side of this part in its origin. And then The next operation, we have to sacrifice tolerance from right to left. If we keep this flat surface against the vise, which is going to be a fixed part of the vise, which is more reliable than clamping on this curvature. So we're going to flip the part like so, and we'll move the origin just for that one operation over onto the right side. With probing, that's pretty quick. We'll keep our origin over on the left for most operations. That way we're basing our tolerance of the chamfers on the second side of the part to the same reference that they were made on the opposite side of the part. Then our last operation is going to be to stand the part up on end and drill and tap this hole here. Alright, let's go to it. So we're going to start off with the part in the orientation something like that. We're going to open up the data plane. We're going to pull in our generic vise. Remember, it should say 2025 on the end of the name of it. And we're going to use the tallest parallels we have. And we're going to flip this vise over 180 degrees. And then we're going to move it back. Roughly in position. And then we're going to use a series of joints to connect these. Now, if the little anchor symbol shows up by this part, we need to unground it from parent. Okay, so let's go ahead and hit OK on our location. And we're going to unground from parent, and that'll allow the vise to continue to move around. Occasionally I have a student that doesn't notice that, and then they have they're having trouble moving the vise into position. Alright, next step, we're going to do a joint to center this on the vise jaw. Now our real origin when we go to machining is going to be the edge of the part, but we want it roughly centered, and because on the following ops we need this part sticking off the edge of the vise. So we're just going to go even. We need 580 thousandths minimum on this side. But if we do it even, we'll have about 1 inch because the part is about 2 inches longer than a 6-inch vise. Okay, so let's go to assemble, and we're going to use the width selection, and our width selection is going to be the vise jaw for the first item, and then we're going to pick a target snap of the middle back of the parallel, okay, and that'll align that snap point. And then on our stock piece, we're also going to do it based off width, and we're going to pick opposite ends of the stock. And then our target will be the center of the stock edge. Make sure the disc's in the orientation that I have it, or flip your part all funky, and we'll hit OK. Alright, so it should be resting on top of the parallel, roughly evenly spaced. Okay, got equal amount on each side. Now we're going to change the distance on the vise to match our material, which is 1 inch, and that'll bring that into place. Okay, so that's our first operation. Second operation, we're going to flip this part 180 degrees about the x-axis. So let's hide this instance of the vise and rotate our part. And we're going to bring in another instance of the vise. We're going to use the same parallels height so that we don't have to move our origin for this second operation. Flip our vise around 180. And then we're going to pull it in a position below our material. Hit OK. pretty much the same procedure, but on this second side, we're going to be clamping on machined edges and not the stock. So we're going to go to bodies and we're going to make the stock invisible. Now we're going to go to joints. Okay, and we're going to pick both sides of our vice jaw again. I'm sorry, that was premature. I picked origin mode. I want to actually pick width. So we're going to pick the width on either side of our component. And then the snap point will be the front edge of the parallel on midpoint. And we're going to go to the same method. We're going to go centered between the ends of our part. And our snap plane is going to be the center of the actual part. Now you see how there's these symbols popping up? They look like little triangles or squares. Those are snap points. That's the center of the surface I'm selecting on. We want actually the center of the body, which is a little bit to the left. So as long as you don't hold the shift key down, this should be the midpoint between the model body. Okay, and that should bring us together. We're clamping against the part on top of the parallel, and there is still the material on top of this. It looks like a hat, but that's not what we want to reference our registration to. If we do this, we can keep the same stop, same parallels as we did on side 1, and we don't have to use any probing other than the very first operation. Okay, we're going to hit OK on our location, and now we're going to change the width of the vise to 3/4 of an inch, which is the width of the part with the sides machined down. Alright, so that'll be the operation to cut the dome top. Now we're going to hide that setup, and the next setup will be to rotate the part like so. We want the flat edge facing the fixed side of the jaw. The curved area is unreliable for clamping, and so we want that on the movable side of the jaw. Okay, so we're going to insert another copy of the vise. I'm going to zoom out a little bit here first. And on this we're going to use 1 1/8 parallels, as we need to be able to clamp on the round on this. And this might be a mistake doing this approach, machining the round first. If you're not careful and you clamp this too hard, you're going to get a flat on that because it's concentrating all the force there. So we want to be careful not to over tighten the vise on these two operations. Probably use about 10 to 15 foot-pounds. Okay, we're going to rotate this 180 degrees and 90 degrees in the other axis to orientate our vise. Move it down. And you notice on this configuration the parallels are different height. So using this method, you'll still be able to keep your X and Y locations set up on the vise, and you're going to put your stop in there. You'll just have to do a Z shift by 1/2 inch on the height of your offset on the machine, because we put in shorter parallels. Alright, so we're going to accept that location, and we're going to use the assemble joint command. We're going to go based off widths. We're going to select either side of the vice jaw, and then we're going to select a snap point of the center of the parallel. Make sure the orange plane is highlighted and the disc is centered on that. And now we're going to do a width of the component. And we're going to select the midpoint bottom edge of the component for our snap point, the center. Okay, should pull that in. Alright, now we need to close the vice jaw, and to measure that, If you go to inspect and you have this show snap points selected, when we hover over a surface, it's going to show the snap points. If you hold the control key down, it allows you to pick on those snap points, so you can pick on the top of the arc, which you can't normally select on. And then the other one, you can just pick on an edge, and that gives us our distance from the base of the part to the top of our radius, and that is 1 inch 225. So we're going to change this to 1 inch 225, and it should close up the vise. What we're looking for is that we're going to hit tangency with the vise. In reality, this parallel is going to have to be spaced away from the rear jaw in order to hit this flat. A common way to do that is put another parallel that's shorter behind this one, so it'll space this one inward a little bit but still keep it parallel, because we need to make sure that we don't block where these holes are.